Okay, here we go. Eyes up here. Anybody do the problem and score themselves last night? Anybody score themselves? All right, score yourselves. Sean, what'd you score? 2 points up. So you got 7. Way to go. Nice job. Adam, what'd you get? You didn't score yourself. Maddie, what'd you get? You got 2 out of 9. Way to go. All right. Jonah, what'd you get? 7. Nice job. Anybody else? Yep. That was my question. I don't know for sure. So let's do it. Okay. All right. Particle moves along a straight line, 0 to t to 5, and velocity of the particle is given by v of t is -2 plus that thing. And the position of the particle is given by s of t, and we know that s of 0 is 10, so it begins at 10. Find all values of t in the interval from 2 to 4, for which the speed of the particle is 2. Well, how does speed compare to velocity? It's the absolute value. So I'm wondering when the absolute value of the velocity is equal to 2. Or I could set up a nice equation. The absolute value of the velocity function minus 2 is equal to 0. That's what I'm going to look for. So I grab my calculator. I turn it on. Go to y equals. Clear that out. And I'm going to enter the function as an absolute value. Absolute value of -2 plus, it is, x squared plus 3x, parentheses, raised to the parentheses, 6 divided by 5, or 1.2, minus x cubed. And then I have to close the parentheses for the absolute value and subtract 2. Okay? So I'm going to zoom standard and see what happens. Okay, I can see it. I like that. I'm going to zoom as a box. Okay, so I made a mistake on this problem when I did it. I found all the spots where it was equal to 0, and it says just find the interval from 2 to 4. So as you can see here, this is 2, and this is 4. So I'm looking for just these 2 spots right here. So I found the third one. I think that they would mark that incorrect. I'm pretty sure that they would. But it's just asking between 2 and 4. So got to be careful for situations like that. So I'm going to do second calculate. I'm going to do number 2 for 0, and I'm going to go over to that spot. And I'll do it again. Second calculate 0, and 3.4734. Is anybody confused about what I did there? I don't have anybody sitting on their cell phone right now, do I? Because I could go nuts at this point after I give you college credit for this class. Write an expression involving an integral that gives the position s of t. Well, position is equal to the start plus displacement. Where does it start? It starts at 10, and then we add the displacement. But we don't know when the displacement is ending, so I put an x here. I put v of t here, dt. Okay. Now I think that the actual answer key has a t here and an x here. Is that right? So right, and there's been a lot of debate from other teachers about this, and I don't know for sure how the AP handles it. If they allow you to switch, or let's say that you actually did just put T there, you put X in both spots. I think that they would give you credit if you took this off and you put say 5 there. Well, then that would be wrong because it's not asking at 5; it's asking at T. But in order to calculate at 5, I'm going to now plug in 5 in order to figure that out. So I'm going to go back to my calculator, and I'm going to go y equals. I'm going to get rid of my absolute value, and I'm going to second calculate number 7. Same exact thing that happened to me last hour. It's amazing. Very interesting function. And we're going to calculate from 0 to 5. Oh, I do not have maximum value of 5. So I'm going to go to 6 so I can calculate number 7. Yep. So I get 10 plus negative 19.20734. So I'll do 10 plus negative 19.20734. And we get that negative 9.20734. And that's the position right now. Okay. So part C asks, find all times at an interval at which the particle changes direction and justify your answer. Oh boy. Particle changes direction when the velocity is equal to 0. Almost. Okay. Positive to negative. Good. So we're going to look at where the velocity of t changes sign. Okay. So this is what they want you to say. They're looking at where it changes sign. So if I look at the velocity function right here, my graph, you can see that changes sign right here and right here, right? So I could say v of t changes from negative to positive at t equals, I'm going to put 0 there it is. We'll do this one first since I'm right over here. So v of t changes from positive to negative at t equals 3.3177. I understand what you're saying, and this is a good learning question. The AP exam wants you to state that when the velocity changes sign, that's when it changes direction. They want you to say velocity, yes. Okay. So then if I do this one, I would do the same thing. Anybody, what do I get? Somebody have it? 0.536? Okay. You have to go to 3 decimal places. A lot of times I just write 4, just in case. Yep. Some people write all 8 decimals. Okay. And then letter D. So particle changes direction at time equals 0.536 and time equals 3.318 or 7, however you want. Okay. So, what do we got? Where am I? Oh, it's up here. Part D. Is the speed of the particle increasing or decreasing at time is equal to 4? Well, what I got to do when they're talking about the speed increasing or decreasing, I got to check v of 4 and I got to check acceleration at time 4. I got to find out what those are. And when and I will say that they want you to understand acceleration is v prime of t. We all good there? So v prime of 4 is equal to the acceleration at time 4. So making that statement is important. I know you assume it, but on our calculator, we're pressing derivative, right? So that's what you're communicating. So right here, all I'm doing to find v of 4 is I'm doing second calculate a value. Number 1, I'm plugging in 4. That's giving me the velocity function at time 4, which is negative 11.4757. But I don't do that for the next one. I do second calculate, and I'm doing number 6, which is derivative. That's why I should state here to let them know that I knew to take a derivative. So the derivative at time 4, and I get negative 22.2957. And so the speed is increasing because A of 4 and V of 4 have the same sign. Excellent question. You would not get docked for that because it's not your final answer. In fact, if you just simply said that v prime of 4 is less than 0, just show that it's negative, you could look and say it's you know that it's headed downward. You know, as you look at the graph, you're like, well, the slope is negative. As long as you justify it, they would give you those points. Just in practice, so if you rounded that off, I'm guessing that's fine. I haven't actually done one of the scorings before. I'd like to do that at some point, but you do have to be selected and apply for it. And I just haven't gone through the work yet. And it's like a week and a half out of your summer, and you just have to decide if that's what you want to do. Anyway, okay, so let's check the answer key and see how we did. So I'm going to go to this page right here, which is my, which year are we in? 13 SG for scoring guide. I click view, and I'm going to look at number 2, and let's see if we find any inconsistencies here. For 1, it says 3.128 and 3.473. First of all, you have to consider the did we write this down? And we also wrote minus 2 equals 0. If you would have just written the minus 2 equals 0, you would get those points. But I want to be clear. If you don't write down this point here and you just come up with the answer, you don't get that point. Okay? So I'm just trying to help show you how you get all those points. Obviously, if you got the correct answer, you knew what you were doing. But they want you to write down kind of what you're plugging into your calculator, what you're thinking through. So they'll give you a point for that justification. We wrote down the integral correctly. I can't answer about the t or the x and how they handle that change. But we plugged in 5. We did get negative 9.207. We get 1 point for the s of t and 1 point for the s of 5, which is what we got. Okay. C, v of t is equal to 0 at those spots. We wrote those spots down, and we said v of t changes sign from we actually wrote it just like this, didn't we? That's what they want. Okay. So a particle changes direction at those times. V of 4 and A of 4 is V prime of 4. Those are both negative. Speed is increasing because velocity and acceleration have the same sign. So again, it tells you exactly how they award the points accordingly. Now, again, your prime motivation is that in a couple weeks you're going to be given a practice test that you're going to be scored on, and so you want to be able to get some points off of this. I would say you should be shooting to try to get at least 3 points on these. Okay, we want to try to come up with that. Now I know that some of these are a lot more complicated than others. I get that. All right, so you ready to try one more? So I said we would score this one day. We're going to try one more. Then you have 2 for homework that you do on a separate sheet of paper. So let's move to problem number 5. Rate at which people enter a auditorium for a rock concert is modeled by this function R. So first thing I notice is that I have a rate function. I'm happy about that because that's primarily what we've been given over the course of this year. We've been looking at rate function in these situations. R of t is measured in people per hour. Okay. No one is in the auditorium at time equals 0. And when the doors open, or the doors close and the concert begins at time is equal to 2. So what's happening here is at time 0, the doors are open finally. And at time 2, the doors close and the concert begins. In the meantime, people are coming into the auditorium, and they're actually maybe waiting a little bit, you know, before they actually get to be seated, or they're waiting outside in the cold, but they're waiting, then they're going through doors or sitting down. Okay, so it says how many people are in the auditorium when the concert begins? A lot of people would say 0, but it's not. The concert doesn't begin at time 0. The concert begins at time 2. So how do we figure out the total number of people that gather during that time? We're collecting. So your integral shows that collection. So anytime we take the integral of a rate function, it's going to show that full collection. So the integral of r of t dt. And what is the time period at which we're gathering those people? I swear that woman. Yeah. Okay. Where am I? Calculator. Let's type it in. Okay. So I needed a different email for it because I'm trying to send her a compressed file, and the school one won't handle it because it doesn't like to receive zip files, as sometimes they're dangerous. So anyway. Yes. All right. I've got a great story for you guys later. All right. Not right now. So I'm going to zoom standard. Oh, no, I can't see the top of the graph. What should I do? Change my window, and let's say that, I don't know, 1,000 people per hour? Well, I don't know. I'd rather, you know, let's see what we get. Ooh, kind of like that. I'm going to do -5 to 4. Okay, like that graph. All right, so now what? Wouldn't it be awesome if we could just do the AP exam together, like me and all of you? Like a big partner test? Nobody would know. Oh. Yeah, we all get these same exact answers, same exact score. Yeah. Yeah. Yep. And somebody's got to take a hit for the team and just get a 1. So somebody's got to do it. All right. Oh. All right. All right, part B. Let's see if we get this. Find the time when the rate at which people enter the auditorium is at a maximum. We want the rate to be at a maximum. How do we maximize something? F prime of x, and we look for where it changes from? Positive, negative. So we have to consider when r prime of t changes from positive to negative. Now, can we come up with R prime? How do you take that derivative? What do you get? (2760) x t. Is it t squared? What do I got? I don't even know. Okay, t. Okay, minus, what's 3 times that thing? What? 2025 t squared. Okay, so that's R prime of t. I'm going to look at where that changes from positive to negative. So I'm going to go to y equals and go get some brain food. Come back and be smart. Okay, let's go. We're in part B. Let's catch back up here. It says find the time when the rate is at a maximum. And you guys told me that a derivative, okay, we're going to have to to find a maximum, we're going to have to take the derivative and look where it changes from positive to negative. So I'm going to look at R prime and look at where it changes from positive to negative. We found R prime, 2,760t minus 2,025t squared. I'm going to plug that into my calculator. 2,760t minus 2,025t squared. And I'm going to check that graph. And as I look at this graph, you can see that here's what it wants you to do. Okay, so, well, first of all, it changes from positive to negative right there, right? Okay, so it changes from positive to negative. We're going to go second calculate a 0, number 2, and enter. T equals 1.3629, okay? That's a time when the rate is at a maximum. Now, I want to show you why the answer key expresses it the way that it does. And maybe I'd get points off for this. I guess I'm really not sure. I'd have to look a little bit deeper, okay? But anytime you're checking for that spot where it crosses over from positive to negative, the question is, when is it at a maximum? Well, this is a closed interval from 0 to 2. And if you remember, when we checked for maximum values in a closed interval, we had to check r of 0, r of 2, but then also where the derivative was equal to 0, r of 1.3629. Here's the idea, folks. If I look at this graph right here, okay, and you find where the derivative is equal to 0, derivative is equal to 0 right there, right? But is that the overall maximum? It's just a local maximum. So it wants you to check 0 and 2 in order to determine the overall maximum. Now, in this situation, r of 0 is 0 and r of 2 is 0 because no people are coming in at time 0. I think. I don't know. I guess I can't remember. Let's look at the graph. If we plug in r of 0, we definitely get 0. And I think, yeah, if you plug in 2, you get 0 as well. So, oh, it's 120? So r of 2, so we could just go to our calculator and plug it in if we want to. What's the function again? 1380 t squared minus 675 t to the third power. And when you do that, if we go to our table and we check 0, 2, and 1.3629, you can see that we get 0, 120, 854. So we've checked the endpoints of the interval. I don't know. I don't know if they're going to require you to do that to get the points. I know they show it in the answer key, and technically we should do that, but okay. Okay. All right. All right. So let's do letter C then. We figured out 1.3629. It says that's the time. Part C looks really complicated. It's actually really quite simple. It says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters and ending when the concert begins. Function W models the total wait time for the people who enter the auditorium before time T. The derivative is given by this. So this is the rate function of the wait time. Whoop. Bless you. That's the rate function of the wait time. Okay? It says find W of 2. How does W compare to W prime? It's the antiderivative. So this is simply saying find the antiderivative at 2 minus the antiderivative at 1. Or in other words, simply find the integral from 1 to 2 of 2 minus t times r of t dt. That will tell us the total wait time of people between the hours of 1 to 2. Right, so I'm going to go to y equals, and I'm going to put parentheses here and at the end. And I'm going to go back here, and I'm going to insert parentheses 2 minus t. And so now I've got that function in. Now I can calculate from 7, from 1 to 2, $387.5. What is my measurement in? Hours. So that means that collectively, one person maybe waited 1 hour. But if you take all, say, 800 people that are in there during that time, they've waited a total amount of 387 hours. Okay? So, part D, go ahead, question. Yep, second calculated number 7, from 1 to 2. Last question says, I got this wrong when I first did it. It said, on average, how long does each person wait in the auditorium for the concert to begin? Consider all the people who enter the auditorium after the doors open and use the model for the total wait time from part C. So would you guys agree that the average amount of waiting time is the total wait hours from 0 to 2 divided by the total people from 0 to 2. Does that make sense? Well, the total wait hours is going to be this guy that we just did, except what's different about it this time? From 0 to 2. Do we know how many people actually entered from hour 0 to hour 2? That was part, yeah. And so we're going to then take this and divide it by 980 or multiply it by 1 over 980. Now, that's what I did too. Yep. I didn't actually read the problem. I did the problem like 3 minutes. I just flew through it right before my first class. And when I saw this, I saw average. And I immediately went to average function value, which is this guy. You guys remember this? A to B, f of x dx. And to find the average value of the function, we multiply by 1 over b minus a. So that's the average value of function. I immediately went to that, and I came up with an average of like 300 hours per person. Like, well, that's totally wrong. And then class started, and I was like, well, shoot, I'm not going to know how to teach this now. So I quick glanced at the answer key. I saw I came up with 1 over the 980, and I didn't even know the 980 because I wrote the integral correctly, knowing I'd come up with this. So I was like, where'd they get the 980? So now I know. So there we go. Everybody learns. I learned. So let's do this, and we'll come up with the right answer. Find the average wait time I go second calculate. I do number 7. I go from 0 to 2. So I get 1 over 980 times 760 is 760 divided by 980 is 0.7755 what? Hours. I don't know why I always do natural log. Okay. Hours per person. So again, if I want to check that answer, I go to this section. Which hour? I went 2009. Which hour? Oh, I've lost it. Which problem? From 2. So the first one I got right. I did the 0 to 2 is 980. The second one, it says consider r prime t equal to 0. We did that. We looked for where it changed sign. So that was good. Interior critical point, we didn't do that spot. I mean, all I did was just consider, I only considered 1.36. So maybe I would have gotten a point off for not doing the 0 and the 120. Maybe I would have. I don't know. For the No, I'm just saying it's hard to know for sure. I'm guessing that they do want you to check the exterior points. I'm guessing that they do. I don't know for sure. Looks like this one was totally right. This one, when I first did it, I did get a point off. Actually, I would have gotten 2 points off there. So you know. So anyway, these are not easy questions. Okay, they're not easy. Okay. All right. All right, so here's your assignment. Your assignment is to do problems 4 and 6 on a separate sheet of paper, because I don't want you to be handing in this entire packet. Simply do these problems on a separate sheet of paper. Now, here's where we're at, folks. I want to be very clear. I expect you to do them and do them correctly. Here's how I would do it. I would do the problem. I would go through and I'd score myself. And then I would do the problem correctly, looking at the answer key, trying to understand how they came up with what they did. That's what I expect you to do. I don't need the question written down. Please, at the top of the paper, write down 2012 question number 1. Separate sheet of paper, because we're going to have about 5 of these, and I don't want you to hand in 5 of these packets. Okay, right. I just use an example. So you'd write down 2011 problem number 4. Okay. Oh yeah, 2011 question number 1. Yep. 2011 question number 1. We got it? Is this pace okay for us? Do you know where to check your answers? Do you understand that it's not normal to get 9 out of 9 or 8 out of 9 or 7 out of 9? Okay? So get the points you can get.